Good morning to everyone. My name is Patan Akbar Kalandarkhan. I am currently studying VTech second year, second semester in the stream of CSC. Today, my topic is about polymorphism. Polymorphism. Introduction to polymorphism in Java. Polymorphism is a core concept in object oriented programming that allows objects to be treated as instances of their parent class rather than their actual class. It enables one interface to be useful for a general class of actions with specific actions determined at runtime. Java supports polymorphism primarily through method overloading and method overriding. What is polymorphism? Polymorphism means many forms in Greek and refers to the ability of different classes respond to the same method call in different ways. It allows for code that is more flexible, reusable and easier to maintain. Polymorphism is achieved in Java through inheritance, interface and abstraction. Types of polymorphism in Java. Compile time polymorphism, also known as static polymorphism, is achieved through method overloading. Runtime polymorphism, also called dynamic polymorphism, occurs through method overriding. Both types enable Java program to handle objects in a flexible and dynamic manner. Method overloading. Method overloading allows multiple methods with the same name but different parameter listed within the same class. It provides compile time polymorphism because the method to be involved is determined at compile time. Example, multiple add method with different parameter type or counts. Method overriding. Method overriding occurs when a subclass provides a specific implementation of method already defined in its superclass. It supports runtime polymorphism as the method call is resolved at runtime based on the object's actual type. Overloading requires the method signature and return type to be the same as in the superclass. Inheritance and polymorphism. Inheritance allows subclasses to inherit method and properties from a superclass, facilitating polymorphism. Through inheritance, a superclass reference can point to a subclass object, enabling dynamic method dispatch. The relationship is fundamental to achieving runtime polymorphism in Java. Upcasting and downcasting. Upcasting involves treating a subclass object as instance of its superclass, promoting flexibility. Downcasting is the process of casting a superclass references back to a subclass, which requires explicit casting. Proper use of casting is essential to utilize polymorphism safety and effectively in Java. Dynamic method dispatch. Dynamic method dispatch is the mechanism by which Java determines the method to invoke at runtime. It allows Java to invoke the overridden method of the actual object's class, not the reference type. This process is crucial for achieving runtime polymorphism in Java applications. Abstract classes and polymorphism. Abstract classes cannot be initialized but can contain abstract method that must be implemented by subclass. They provide a common base for related class and facilitate polymorphic behavior. Polymorphism is achieved when a superclass reference points to subclass objects invoking overridden methods. Interfaces and polymorphism. Interfaces define a contact with a abstract method that implementing classes must override. They enable multiple classes to be treated uniformly when they implement the same interface. Interfaces are a powerful tool to achieve polymorphism and support multiple interfaces in Java. Example of polymorphism with method overriding. Consider a superclass animal with a method make sound. Subclass dog and cat override make sound with specific implementations. When calling make sound on an animal reference pointing to a dog or cat, the correct method execute at runtime. Example of polymorphism with method overloading. A class calculator has multiple calculate method with different parameter signatures. The method called is determined by the arguments passed during invocation. This static polymorphism helps in providing multiple functionalities under a common method name. Advantages of polymorphism in Java. Polymorphism promotes code reusability by allowing the same interface to work with different underlying classes. It simplifies code maintenance and enhances scalability by enabling new subclass without changing existing code. Polymorphism also improves code readability and reduce complexity. Common mistakes in implementing polymorphism. Overloading methods with incompatible signatures lead to error and unexpected behavior. Using downcasting improperly can cause class cast exception. Failing to declare method with the correct access modifiers can prevent overriding or polymorphic behavior. Best practices for using polymorphism. Prefer programming to interface rather than concrete class to maximize flexibility. Use the override annotation to ensure correct overriding of superclass methods. Keep method signatures consistent across superclass and subclass to avoid runtime issues. Real-world use cases of polymorphism. GUI frameworks utilize polymorphism to handle different UI components uniformly. Collection API uses polymorphism to manage various types of objectives through a common interface. Design patterns like factory, strategy, and observer heavily rely on polymorphic behavior. Limitations of polymorphism in Java. Overuse of polymorphism can lead to complex code that's difficult to debug. Runtime polymorphism may introduce slight performance overhead due to dynamic method dispatch. Proper understanding and careful implementation are necessary to avoid common pitfalls. Summary of key concepts. Polymorphism in Java allow objects to be treated as instances of their superclass or interface. It combines method overloading, compile time, and method overriding runtime. Proper use of inheritance interfaces and abstract classes is essential to leverage polymorphism effectively. Conclusion. Polymorphism is fundamental to creating flexible, scalable, and maintainable Java applications. Understanding how to implement and utilize polymorphism enhances object-oriented design skills. Mastery of polymorphism leads to better code organization and improved software quality. These are the references where we can deeply understand about the polymorphism more clearly. Thank you.